Hi guys. Today we're going to continue on from what we did yesterday and talk about how to use those numbers with the mole to do mole conversions. Okay, so here we go. Let's review yesterday's, the mole is the counting unit. The chemists use. It tells us the number of particles in a substance. It's that big, huge number. Probably the most important thing to this is this right here. It is an equivalent relationship, and we can use it to convert from one to the other. That's the conversion bit of this. Now, this is a big, huge number, 6.02 times 10 to the 23rd. The next slide is, so the funny thing is that this kind of goes along with the slide from yesterday, molar mass and Avogadro's number. I should say a small mass equals a huge number of atoms because it's such a big, huge number. I really like this definition, so I stuck it in here. It's the number of atoms required to measure out the mass of atoms in grams. So when you again weigh out 6.02 times 10 to the 23rd atoms, you're going to equal the amount of grams that's listed on the periodic table. That's what that is saying. So the reason why this number is so huge and this little bullet right here, that the value isn't really important in everyday chemistry, but knowing that when you see the word mole, it represents this number of atoms or particles or whatever, that number of pieces. It is the fact you're going to see this number, and it's called Avogadro's number, and in future chemistry classes, they're going to make you do conversions with it. Not here, because, well, people punch it in their calculator wrong, and it's so huge and confusing. So here's the funny thing about it. Like, when you divide the number of moles by 2, so like people are like, oh, well, we're going to half it. So check out what happens when you half this number, when you do 6.02 times 10 to the 23rd, it's so big, you would think, oh, you're going to reduce a couple of zeros. No, 1/2 of a mole is 3.01 times 10 to the 23rd. So 301,000,000,000,000,000. Okay, you get it, right? Dot, 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 dot. Like, it's a massive number. Half of it, all it does is change the front number to half of it. Like, it's still a number of zeros. So back to that video that you watched, the TED Ed, was all about just how insanely large this number is. The other definition we saw that's really important for today is molar mass. It's the mass of one mole of atoms. It's the same as atomic mass. I just said that. Again, this is also an equivalent, so we can use it to convert. So the mole road, so I found this. Look, it's a little, can you see it? Look, it's a little mole. And he's like got goggles, and he's funny. It's like a poof ball. And on the little tag, it's from the American Chemical Society. That's what ACS stands for already. It says, the mole is a chemist's best friend. And that's why I did this chart. So the mole, right there in the middle, the mole is equivalent to all of these things by, well, okay, the mole is 1 mole equals 6.02 times 10 to the 23rd representative particles. 1 mole equals the molar mass of a substance. Now, volume of a gas, this is something I don't know if we're going to cover, but I'm going to tell you anyway. Oh, I know why I'm saying it, because it was on the video. And funnily enough, we did a lot of things with Avogadro's number, and that the same size container has the same number of particles. That was unit 4. The volume of a gas, 1 mole will equal 22.4 liters. Now it's at standard temperature and pressure, meaning 0 degrees Celsius sea level. So if you want to go back to that video, it was a really good one. That's how Avogadro came up with this number: standard temperature and pressure, 0 Celsius. I'm not gonna make you know that. Just know that's what it means. Volume of a solution is something called 1 mole. Oh, whoa, too far. So 1 mole is equal to well, it's moles per liter. So actually, volume of a solution is number of moles in 1 liter of solution. But really, okay, so the whole idea is that all 1 mole, 1 mole, 1 mole, that one's just a little different. I don't think we're going to get to that, but if we do, I know this is my horrible handwriting, but I'm trying to write on my screen and do this video at the same time. So the mole is a chemist's best friend because the word mole is it is a unit to count things. When you say a mole, why are we not going to use this big huge number? Because no chemist ever goes, oh well, in this jar, ready? This jar of table salt that I did previously has, ready? I don't think I've opened it, but if I did, it's got 50 grams of table salt. Okay, ready? Ready for how to do this? Table salt. This is 50 grams of table salt, but its weight is 58.45. Nobody's gonna go, oh, well, that's, well, it's not a whole mole. It's 0.8 of a mole. I told you, just made that number up. So that means it's got 5.99 times 10 to the 23rd atoms. Like, no chemist does that. They're like, oh, it's part of a mole. It's half of a mole. It's 3/4 of a mole. It's 0.8 of a mole. Whatever. Nobody uses that number. You might have to in a college chemistry class. When you get there, let me know. I can help, but it's not that no chemist does that. So here, okay, so these equivalent signs, remember the equal signs? 1 mole is equal to the molar mass of a substance. This step right here, this is the conversion we're going to do today. How to change between mass and mole. And there's our conversion factor. I wish I could find that paper that has all the conversion factors on it, but this is it. So, ready? I'm just going to do a bunch of examples because that's easy. This conversion factor is 1 mole equals molar, the number, whatever number it is, the molar mass in grams. Okay, so ready? Let's just write that. Okay, so it's iron. You're gonna need a periodic table. Look, I stole this somebody's packet that didn't put their name on it, so I'm using it as a reference. I think I have to exit. This is a PowerPoint I'm just running this through. I might have to exit out of. Reference the Google site. Just flip back and forth. Have a double screen. Reference your periodic table. That's how you do these kind of things. So iron, right here. Iron is 55.8 something. So that conversion factor would be 1 mole equals 55.85 grams. So, remember conversion factors? Every single one of these is one step. So our starting number is 7.67 grams of iron. And I'm going to put Fe on here because the unit is actually important. Let me go back to the mole road really fast. What if I went from here, mass to mole? Then that would be a 2-step conversion. If you keep the units in, then you'll know. So this really should say 1 mole of Fe is 5.85 grams of Fe. So, gee, where do those numbers go? Grams, grams. 55.85 grams is 1 mole. Still Fe. I don't know. Oh, no, darn it. Okay, so math-wise, multiply our crop, divide by the bottom. 7. Okay, calculator, yay. 7.67 divided by 55.85, that is point. Okay, can you point a big, massive amount of numbers on there? Do we need all those numbers? No, we just need the 3 that are right there. So the answer is 0.137 moles of iron. Okay, example number 2. It says calculate the mass of water, should say molar mass of water. How many moles of water in a drop of water? So we have, that's the first step. This is your compound. If the molar mass is not given to you, you have to calculate it. It is not always going to say that in the instructions, but the mass of water. So the formula of water is H2O, right? Hydrogen is 1.01 times 2 plus 16.00. I did that really fast. That is going to be 18.02 grams per mole. So the per really conversion factor, 18.01 grams equals 1 mole water. So this is our starting number because it's the only number in the problem. 0.090 grams H2O. 18.0, oh wait, not 01, 02. 02 grams H2O is 1 mole, technically H2O. Okay, 0.090 divided by 18.02. I guess we could talk about this. So that's 0.00499. And we just need 2, so technically it's 499. That'd be 50 moles H2O. So this is the conversion from grams to moles. Yeah, divide because moles are bigger. Remember with the egg and the quail, chicken egg and quail egg, chicken eggs were bigger, so we divided. Same thing. So the first 2 examples were how to convert moles to grams. Woo! Okay, we just got a mini interruption by my daughter and the guinea pig. FYI. I got to get the guinea pig from school. I don't know if you can see him in there, but he needed a home and Mr. Cranky was going to just leave him in the courtyard, so I got him. All right, 2 more examples and then you get to do 4 problems and then you're done. So, okay. Example number 3, what would the mass of 0.0030 moles LIBRB? Mass is grams. Again, this one doesn't say find the molar mass, but that's the conversion factor. So the first thing to do is find the molar mass at LIBR. Again, its mass is lithium is 6.94 and Br is 6.94 plus 79.90, 86.84. So you heard me say that grams per mole. Again, grams per mole. So okay, now this is our starting number because it's 00 moles. 0.0030 moles LIBR. Now here's the conversion. Gee, okay, you know how like I used to ask which goes where? Well, if moles is here, so the 1 mole goes in the bottom and the grams goes in the top. 86.84 grams. Technically you should write LIBR, but it's still moles. So 86.84 times 0.0030 is 0.26052. 0.2605. I don't think we need any more numbers than that. So that would be grams of LIBR. All right, last one. Hopefully I'm not going too fast, but the beauty of a video is you can always go back. So again, Now, don't be thrown off. This says if a student needs 0.25 moles of magnesium, that's MgSO4 is magnesium sulfate, for a lab, how much should the student weigh out on a balance? Well, it's the same thing. Just because it says in the